Note to self, music goes here. Accurate counting of cells is important in many aspects of science and biology, whether in immunology, cell biology, cancer research, brewing beer, or even doing a sperm count. Accurate and repeatable counting of cells is important for meaningful and reproducible results. Problem is, it's a bit boring. When someone showed me how it was done, I thought they were taking a new guy on a snipe hunt. Basically, you use a calibrated slide called a hemocytometer. It has precision markings and a carefully calibrated distance between a slide and cover slip. Most cell counts are performed in a square that is 1 millimeter on each side and is 1/10 of a millimeter deep. This gives a volume of 0.1 microliters. So for instance, if you count 100 cells in this square, the cell density is 1 million cells per ml. The way you do this is by looking through a microscope at this slide. The square is subdivided into 16 squares for convenience. You press a button on a tally counter for every cell you see. Now continue counting through all 16 squares, and now imagine you have 20 more samples to finish. And this is all before the real science begins. When somebody flashes up a few fingers for a split second, you don't count the fingers individually. You recognize the number by sight. This is subitizing. When you look down at the cells, it's easy to discern groupings of cells. For example, 3, 4, 2, 3. So this is SubiCount. It's powered by the MSP430-2211 chip. There aren't too many parts to this. There are 3 buttons. It's powered by 2 button cell batteries. The battery holder is actually custom made out of polymorph. This is a tally counter that I got for about $2 from Deal Extreme. Here is the MSP430 with just a bypass capacitor, 2 base resistors, and 2 NPN transistors for interfacing with the tally counter. So the 3 buttons are for 1 count, 2 counts, and 3 counts. And the buttons are debounced and fully independent, so that if you press all 3, you get 6 additional counts, and you can go in whatever order you want. So if you hit 1, 2, 3, and then release in that order, you get 6 additional counts, and you can go also in the other order. You go 1 and release in whatever order, and it doesn't really matter. The only time that the keys are not independent is when you want to reset the counter, in which case you hold down all 3 buttons for about 4 seconds. So if you hold this down, it should reset, and it works quite nicely. It'll keep up with however many presses you can put in. So let's do a couple of quick button presses. I'll do all 3 buttons to give 6, and I'll do it for a total of 10 presses, so it should count up to 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it happily counts up until it gets up to 60. Let's hope it stops exactly at 60. And it does. So another 10 just for grins, because I like my new project. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should get it 120 and then stop. And so this is running in LPM3 mode while it's processing the buttons, but when there's nothing going on, it goes into LPM4 to save the batteries. When I did this, the first version of the firmware, I was polling constantly at LPM3, so regardless of what was going on, so 24/7, it was waking up 100 times per second out of LPM3 to check for button presses doing the debounce, and the 2 button cells lasted for about 3.5 months. So I'm hoping that with this better firmware that goes into LPM4, that'll last a lot longer, possibly maybe a couple of years. So we'll see how it goes. Once again, this is how it goes. Reset, and you can count to your heart's content.